Okay, today's lesson is going to focus on writing cohesive lines from table of values and points. Now, the good news is we're really going to take the same approach we used in the last video when we wrote equations of lines from graphs. We are still going to write everything in point slope form, all right? So let's go ahead and recap what we know from our prior lesson. So if we look at, all right, our line here, I'm going to go ahead and identify 2 points on the line. So here's a point and here's a point. All right, so the first thing we're going to do is find our rate of change. All right, so if I go from point number 1 to point number 2, I go down 3 and over 1. So my rate of change, my slope is -3 over 1, which is -3. So now all we need is a point. And since I have this point right here, this is -3, 3. So -3, 3. All right, for my point. And therefore, we can take this information, and we said that we can write an equation in point slope form. All right, so y would equal to -3, x minus -3, which becomes +3, and then +3 out here. And so there's our equation of our line from a graph. Now, what we're going to do is this exact same process, all right, that we focused on last time with graphs, but now our information can be given to us in a different way. Now, instead of having a graph, we might have a table of values. Now notice, we still want the same information. We still want rate of change. We still want a point, and so we can write our equation in point slope form. Now, so the only piece that changes when we're working with tables is how we find our rate of change. Now, when we did it graphically, we said our slope was our rise over run. Now, when we think about things numerically, all right, with our table here, instead of thinking of rise over run, what we want to think of our rate of change is the change of y over the change of x. All right, you might see this as dy or delta y over delta x. So the change in y over the change in x. So when we look at our table, we just need to look at the ratio of those two changes, and we will have our slope or rate of change. So if I look here from our first point to our second point, I go from -3 to 2, so our y increased by 5. From 0 to 1, our x increased by 1. So it appears that our slope would be 5 over 1 or 5. Now notice, if we go from any 2 points in this table, we get the same, all right, rate of change. So from 7 to 12 is an increase of 5. From 2 to 1, or excuse me, from 2 to 3 is an increase of 1. From 12 to 17, that's an increase of 5. And from 3 to 4, that's an increase of 1. So if our data is in fact linear, it should not matter what 2 points we pick on the table, all right, we should get the exact same rate of change. Now, for these examples, we're going to assume, all right, that the data in our table is linear. And we'll talk about on our final example how to determine if something is linear or nonlinear. Now, once again, a point, just like we did on a graph, we can pick any of our points that we want. So I'm just going to pick the point 2, 7. And then we can take that and plug it in to our point slope form. So our slope is 5, our point is 2, 7, and there's our equation. All right, so that is all we have to do. So notice that really the only big change from our prior lesson is how we look at a rate of change with a table versus a graph. All right, so let's take a look at another example. All right, so once again, all right, so we need rate of change, we need a point, and then we can write our equation in point slope form. All right, so once again, it should not matter which points we pick. Now, what we always want to do is look at our table because our x's may or may not change the same way, so we always want to make sure that we pay particular attention to that. So for example, when I look from first point to second point, my y increases by 1. Well, if I look at my x's, I go from -2 to 0, so that's an increase of +2. All right, so that would mean that our rate of change is our change in y over our change in x, so that would be 1 over 2. And notice no matter where we go, all right, in our table we should get something equivalent to that. So notice if I go from 2.7 to 6.9, from 7 to 9 is an increase of 2. From 2 to 6 is an increase of 4. So that would be a slope or rate of change of 2/4, which does reduce to 1/2. So no matter what 2 points we pick, we should get an equivalent form of our slope. Now, all I have to do is pick one of our possible points. All right, so I'm just going to pick the point 0.06. All right, and then I can take this information and I can just plug this in. All right, and there's our equation. If I want to simplify here, since x minus 0 would just be x, I would in fact get y equals 1/2 x plus 6, which happens to be slope-intercept form, since I picked 0.6, which is the y-intercept. All right, so let's look at another example here. All right, so once again, all right, we're going to find our rate of change and the point, and then we're going to write our equation in point-slope form. All right, so now when I look at this, I go from 24 to -8. Now, the first thing you should see here is that our slope, all right, or our change in y decreases. It goes from 24 to -8, so that means it went down. So it's going to be a negative change in y here. And from 24 to -8 would be a change of 32. Now, x, on the other hand, goes from -3 to 1, increases, and it increases by 4. So that means our rate of change is -32 divided by 4, and if we were to reduce that, would be -8. And notice, no matter where we go on our table, once again, if I go down here, from -4 to -2 is a change of -32. From 5 to 9 is a change of +4. So once again, we get an equivalent rate of change, right, from those 2 points. Now, once again, I can pick any of the points here. This time, I'm just going to pick the first point. All right, a -3, 24. Just to review, all right, one particular detail. So let me go ahead and write our point slope form here. So our slope is, in fact, -8. Now, x minus x1. So I'm going to be subtracting a negative. So remember, all right, when I subtract that negative, it becomes a positive on the interior here, and then I have the plus 24. All right, so there are 3 examples that we have done together. So what I would like you to do now is I would like you to try this problem on your own. All right, I would like you to go ahead and pause the video at this moment. All right, I'd like you to go ahead and find your rate of change, select a point, and then write your equation in point-slope form. Now what I'm going to do is go ahead and work the problem, and then you should be able to compare your answer to what I'm about to write. Okay, so once again, if I were looking at rate of change, if I go here, it's a +1. If I go here, that's a +1. If I go here, it's a +1. If I go here, it's a +1. So our rate of change in this example is 1/1, which is 1. And then if I pick the point 77, all right, I would get the problem y equals 1 times x minus 7 plus 7. Now, once again, remember, if you did not pick the point 77, your equation would look different from mine. Now, your slope should be the same. Now, remember what we discussed in prior lessons is that if I wanted to find out if you were right or equivalent to what I have, I can convert this to slope-intercept form. So I could distribute. So y equals 1x minus 7 and then plus 7. And then I would get y equals x. So if you were to do the same thing to your equation, you should also get y equals x and would know that you are correct. All right, so how about another example for you to work on your own? All right, so once again, go ahead and pause the video, find your rate of change, your point, and write your equation in point-slope form. And I will do the same so that you can check your answer. All right, now, what I did, because I just noticed here that I had, all right, some decimals here, and I may or may not want to work with that, is I'm going to go from whole number to whole number here. So I'm going to look at my rate of change from -1 to 2 here, which is an increase of 3. And then I'm going to go from 0 to 2 here, which is an increase of 2. So notice, since we can pick any 2 points to work with, if we have a number that looks kind of funky or that we don't want to work with decimals, we can work with the whole numbers here. So then my slope for this particular problem would be 3/2. All right. And if I pick the point 2, 2, all right, my equation ends up being y equals 3/2 x minus 2 plus 2. Now, once again, if you want to compare your equation to my equation to see if they're equivalent, we would just need to convert both to slope-intercept form. So that would be 3/2 x minus 3 plus 2. And if we combine like terms, 3/2 x minus 1 is this equation in slope-intercept form. So convert yours, and then if they match up, you know that you are correct. All right. One final problem here for you to do on your own, and then we'll check this together. So go ahead and pause the video and try this one. Okay, so if I look at my rate of change here, I go from 14 to 2, so I went down 12. And then I go from -2 to 1, I go up 3. So it looks like our rate of change is -12 over 3, which is -4. All right, and so notice if I pick another point here, or another 2 points, so if I go from here to here, that's -4. If I go from here to here, that's a +1, and that is -4. If I were to go from here to here, that's -16. If I were to go from here to here, that's a +4, and then once again, -16 divided by 4 is also -4. So once again, it does not matter which 2 points you pick, you should get the same slope. I'm going to go ahead and pick the point 1, 2 to work with, and then point slope form would be y equals -4, x minus 1, and then plus 2. And once again, if we want to check and see if we are correct, that would be -4x plus 4 plus 2, which would give us slope-intercept form of -4x plus 6. All right, so there's several examples on how to, all right, write this equation, all right, from a table of values. Now, what if we just have 2 points? Well, then our process is narrowed down considerably, right? So we're going to do the exact same thing, all right? No changes in what we're going to do. We first have to find our rate of change, all right? Then we have to pick one of the points, and then we have to write the equation. Okay, so now notice, when I go from -9, all right, so when I go from -9 to -15, all right, that's my change in y, and I went down 6 units. All right, when I go from 23 to 35, all right, I went up 12 in the x direction. So then our rate of change would be -6 over 12, which is -1/2. And then now my choice of points, I just have 2 choices. So I'm just going to go ahead and use the first point just to make things simple. And then our equation would then be -1/2, x minus 23, and then -9. And there we are. So it really just makes things easier because we only have the 2 points to pick. All right, if we look at example 2, if I go from -4 to 2, I went up 6 in the y direction. From 0 to 1.5 is an increase of 1.5. All right, so then what I know is my rate of change, all right, is my change in y over my change in x. And then if I were to divide that out, I get 4. And then once again, just to make things simple, I'm going to take the first point there, and then I can write my equation. Y equals 4, x minus 0, and then minus 4. And then once again, if you simplify the x minus 0, that would just be y equals 4x minus 4. All right, there we go. All right, now one final example here. All right, so this is kind of something that we need to look at. All right, so pay particular attention to this example. So notice our change in y, no big deal. That's a +10. But notice here, our change in x is 0. Now, so this is significant because then if I think about my rate of change, it's 10 over 0, which we cannot do. All right, so this is undefined. Now, what this tells us is that we do not have a function here, okay? All right, remember, we have a special case. If something is not a function, that means it is a vertical line. We have to use the special form x equals a. So in this case, that means the equation would be x equals 10. So if our rate of change ever ends with a 0 in the denominator, that tells us that we do not have a function, that we have 2 points stacked on top of each other, which means we do not pass the vertical line test, which means it's not a function and we have to use our form of a vertical line, which is x equals a. All right, one final thing. All right, now, with all the previous problems that we worked, we assumed that the data was in fact linear. Now, Sometimes, and this may happen on a standardized test, may happen in other situations, but you always want to make sure your data is linear. Now, the way you know your data is linear is that every slope, all right, should come up to be equivalent. So if we look at our first table here, all right, so notice I go from 6 to 11, that's an increase of 5, and from 4 to 6, that's an increase of 2. So our first rate of change is 5 over 2. If we look at our second rate of change here, that's an increase of 10 and an increase of 4, which is 10 over 4, which is also 5 over 2. So this is, in fact, linear. Now, I'm not going to write the equation because you would do that the same way we just did, but I wanted to make sure that we understand how to determine if something is linear or non-linear. All right, so if it's linear, all right, all the rate of changes between any 2 points must agree. So if we look at our second example here, 1 to 4 is is a positive 3. Negative 2 to 1 is a plus 1. So the rate of change between the first 2 points is 3 over 1. Now if we look at the next 2 points, this is a plus 5, and then this is a plus 1. So the second rate of change is 5 over 1. Okay, these do not match, therefore this must be a nonlinear set of data. All right, and finally, all right, so plus 0 and a plus 2. So our first rate of change is 0 over 2, which is 0. Our next would be a plus 0 and a plus 4, all right, which is 0 over 4, which is also 0. Those agree, therefore this data must be linear. All right, so there's a look at writing equations from tables and points. All right, so make sure that if you have any questions over this lesson, you have them ready for class tomorrow, and we'll jump into worksheet Unit 4.2 to begin class.